In networking, reference architectures are what a network architect is referencing when they're trying to build their own network architecture. There were initially two competing network reference architectures. The first one was called OSI, or Open Systems Interconnect. It had 7 layers. And then the second one was called TCP/IP, and it had 5 layers. Eventually, they were merged into a single hybrid architecture or reference architecture called Hybrid OSI TCP/IP architecture, and they ended up with 5 layers. As I said, OSI has 7 layers, which is starting with application, presentation, session, network, data link, and physical. And the data link layer and the physical layer are still very popular. However, the rest of the layers in the OSI reference architecture are not really being used anymore. The presentation layer of the OSI reference architecture is mainly there to address data presentation issues. Therefore, the presentation is mainly designed to reconcile differences in formatting when two different hosts are trying to exchange messages. The presentation layer is also responsible for encoding, encryption, and compression. However, in reality, the presentation layer is rarely used because a lot of these features are now taken care of by the application layer or other layers. A session layer is meant to be initiating and maintaining a connection between the two hosts. For example, in a database transaction, let's say a failure happens in the middle of the transaction, and if you have a session layer that keeps track of what's going on in the transaction all the time, then you can simply go back to a particular rollback point where the failure actually happened. So instead of starting from the beginning all over again, in this case, you can simply go back to the place where the failure occurred and then simply go on. One of the problems associated with the session layer is the fact that it causes too much overhead. So only a few types of applications can benefit from something like this, such as FTP or database transactions. So can you imagine when you're trying to download 1 gigabyte of data and then right in the middle, let's say halfway done, somehow something happens and then you have to start all over again. So for something like that, session layer is great, but at the same time, it just has too much overhead and not every application requires something like that. So again, because of this reason, the session layer is rarely used, and whatever that needs to be done in the session layer is really handled by other layers, such as, again, an application layer. The TCP/IP reference architecture has 5 layers. It of course has the application layer. It also has transport layer and the internet layer, as well as data link and the physical layer. However, the TCP/IP reference architecture version of data link and the physical layers are not as popular as the TCP/IP reference architecture versions of application, transport, and the internet layers. Therefore, what ended up happening was this creation of hybrid reference architecture, which has some elements of the TCP/IP reference architecture and also some elements of the OSI reference architecture. So the hybrid reference architecture still has 5 layers, just like the TCP/IP reference architecture, and it does have the application layer. However, in this case, the transport layer and the internet layer are coming from the TCP/IP reference architecture, while the data link and the physical layers are coming from the OSI reference architecture due to their popularity. The application layer is really dependent on the application developers when it comes to their protocols, so they are really not part of any of these reference architectures themselves.